now we're going to do rational equations. That means we're going to have fractions. Okay?
Okay.
So we're going to be doing these with fractions. So they're going to look like this. Okay?
Okay.
We've done some similar.
Yeah.
This is actually one you have very likely have done before. And so we're going to review it. What do we do to get rid of that fraction?
You have to do the reciprocal.
We would if we had just x over 5. No.
Yeah, if we were dividing.
We had like 1/2 x equals 7. But this time we have the x, we have multiple fractions.
Yeah. Oh, do we have to choose a common denominator?
Yes, we multiply by the common denominator. What's the common denominator of 5, 2, and 10?
10.
Yes, we're going to multiply by 10.
Oh,
on this side.
yeah, I remember doing this.
And I actually like to write the 10 all over instead of doing the distributive property. But
Yeah, I've done
okay.
this before.
Yes. So 5 goes into 10.
2 times.
Two
it's
times.
2x.
So it's 2x. 2 goes into 10 5 times, so it's going to be a 5x. And 10 goes into 10, leaving me just 49. Now this looks beautiful, like we've been doing long before.
Yeah, so it's 7x equals 4. Oh, x equals 7.
Yes, divide by 7, and x equals 7. Okay? Now, when you're doing these, you need to make sure that when you start out, you look, was there an x in the denominator?
No.
Okay. If there is an x in the denominator, you have to make sure that you don't, we have to make sure that our answer meets with the domain which we just studied. Okay? So let's do one, and I'll show you what I'm talking about. Right here, I have an x in the denominator. Okay? 3 times x. We got to make sure that x can't be what number?
0.
0, because 3 times 0 will give us a problem. So up here on the top, I'm just going to write x cannot be 0. If, and wait, I need to do something. Just a second. Okay, x cannot be 0. If our answer when we're all done is 0, then we will say that this problem has no solution, because we can't get 0, because 0 is not allowed to be in the denominator of the fraction. Sometimes we can get, multiple answers. If we do the quadratic, sometimes we get like 2 and 7 or some 2 numbers. Mm-hmm. If one of them happen to be 0, then we would have to exclude that answer and only use one of them. Okay? So let's find out but we always need to look at the beginning of that and say, oh, we can't get a 0, so let's see what happens when we solve it. All right? What's the common denominator of 9 and 3x?
9.
9. I'm going to have to have x. So I'm going to go 9x and 9x and 9x. Okay? So I'm going to I should have done this on the other one, get another color. The 9 cancels, and I'm left with an x, right? Mm-hmm. So I'll have x squared when I'm done. Mm-hmm. The 3 will cancel here, and I'll have a 3x. And the 3 will cancel here with the 3, and the x cancels too on those.
1. Oh, right.
Does that make sense?
Yes.
Okay, I'm sorry if I confused you. Let's go back to, is that the color I had? All right, so I'm going to have an x squared minus 3 equals
6.
6. All right, what do you want to do?
Okay, so I'm going to add the 3 to the 6, so it'll become 9.
X squared equals 9.
And then you have to do the square root, so x will equal 3.
Careful.
Negative and positive.
Yes, now we have to look. We had a problem up here where we weren't allowed to have 0. Is underneath our answer 0?
No.
No, so we are fine with our plus or minus 3. If we would have gotten 2 and 0 or something like that, we would have just gotten rid of the 0 and kept one of them.
Okay.
Okay? All right, so our answers are plus or minus 3. All right, we're going to do this one. This is bigger even. Okay, now we have to figure out what our common denominator is of, in this case, x plus 2 and x minus 3, because we already have the double there.
So x plus 6?
Mm-mm.
Do we have to do the x plus 2, x minus 3?
Yes, we have to multiply both of them. So I'm going to have to really get up here. X plus 2, x minus 3, and then I have to write the same thing over. I like to write them, in your book, they only show the distributive property. But for me to do all my canceling, I need to write them twice. Yeah. X plus 2 and x minus 3. And don't forget over here, this is the biggest mistake, is to forget it over here. X plus 2 and x minus 3. I'm going to have to do that. Okay. All right. Now let's start canceling.
Okay, so then it will be...
How do I do that? All right. What am I going to cancel here?
You're going to cancel the x plus 2.
Yes.
So you'll have 5, or you can just do 5x minus...
I'm going to actually keep my blue, yes. Do you want to distribute it, or do you want to leave it undistributed?
Just distribute it.
Distribute it, because we'll have 5x minus
Minus
15. Okay. So here,
You'll have
this is going to cancel.
and then you'll have 3x plus 6.
And then this is
will
going to
be-
cancel, and
so
these two will
you'll
be
have
multiplied.
2x minus 6. So
I'm going to
then
go
we-
back to that purple color. I think it looks better. All right, so like terms.
Okay, so then we can do 10x
How did you get 10x?
because I added all. We can't add that one, right?
Right, this will move over here.
Yeah. Okay. So we can do 8x.
Yes. And then those two,
Become 9.
okay,
Negative 9.
negative 9, and that's going to be a 2x minus 6.
So then we move that over here by subtracting
Okay.
it. So it'll become 6x
All right.
minus 9.
I'm going to add 9 at the same time.
Yeah.
What does that become?
It becomes negative 4.
No.
No, I mean, this is a negative. I'm sorry. Negative 15.
Careful. When we did that, we're going to add 9.
Add 9. So it will be positive 4.
No.
3.
Yes.
Oh, my word.
And then we're going to divide by 6 and divide by 6.
X
So-
will equal negative 2.
Careful.
Negative and positive 2.
This is a fraction.
Oh! So it'll be 1/2.
Yes.
Yeah.
Now let's go back. We should have looked at this at the very, very, very beginning. I apologize. I told you to do that last time. X. What can X not be?
0.
It can't. The denominator can't be 0. So X plus 2. What plus 2 gives me 0?
What plus 2 gives you 0? Negative 2?
Okay. So X cannot be negative 2. And what minus
positive
3
3.
or positive 3? So did our answer become negative 2 or positive 3? No. So we're fine. X is a half, and that's our answer.
Okay.
Okay, we're going to do one more. And I want us first to analyze what we've done so far, okay? The kind of problems we've had in the past, I have two fractions added together, equaling either a fraction or a whole number. That's not a problem. I had two fractions on one side. I had two fractions on one side, but this next one, I have only one fraction and one fraction. So there is a way to do this one to get rid of the fraction without multiplying by the common denominator.
Okay.
Okay, and so it's called cross multiply. It's where I take these two and I multiply,
Okay, yeah.
and then I take these two and I multiply them. Okay,
Okay, so
so I'll have, if I do just this one, I'll have x minus 1 times x plus 2. And I'll have these ones, I'll have x minus 2 and x minus 6. Before we go too far, what can x not be?
x cannot be positive 1, negative 2.
Oh wait, just the denominators.
Oh. Positive 1 and positive 6.
That's right. So if we get that as one of our answers, we'll have a problem.
Okay.
And it's not a serious problem. We'll just eliminate that answer. Okay? All right. So, what do I do with this?
Okay. Do you do like terms?
No, because you're multiplying.
Yeah. Oh.
If I said the word FOIL, what would that mean? Distribute property.
Okay, yeah.
So we're gonna
So
do.
I'm gonna do. Oh. Okay, so x squared plus 2x
Good.
negative minus, or we can just do minus x.
Okay.
And negative 2.
Okay.
Minus 2.
So the same thing here.
Okay, so x squared minus 6x minus 2x minus 12.
Good. Okay, we're gonna run out of room, but that's okay. We have these like terms and we have these like terms. So we're gonna have x squared.
Wait, do we not add these two?
These are equals. There's an equals here.
Oh, okay, I'm sorry.
It's okay.
So you have x minus 2 equals x squared minus 8x minus 12.
Okay, something really cool is gonna happen in a minute, but I'm gonna need room. Okay, now these x squareds. What's gonna happen to them?
Oh, we can do the box method.
We could, but there's an equal. We got to get everything on one side first, and equal to 0.
So we can subtract x squared.
Yes,
over
if I
2.
subtract this x squared from this side, what's going to happen?
They're going to go away.
They're going to go away. No x squared, no box method even needed. So I'm going to be left with a negative x minus 2 equals negative 8x minus 12. Now what?
Now we can subtract the
Okay.
8x from the 1.
Okay. I'm going to actually add that.
Oh, that's what yeah. Sorry.
Okay, so we'll have...
So it'll be 7x. So then you'll do the same with the 12. You'll add it to the 2.
You want to add it over here?
Uh-huh.
Okay. Now, since we're not going to do the box method, we actually this time now don't want to have everything on one side equals 0.
Oh,
we want to bring it... Oh, yes. We want to add
So
that 2 over here.
it'll be negative 10. 7x equals negative 10. Right?
Yes, 7x equals negative 10. All right. I just realized something. This should have been a plus 12 clear up here, because we had a negative 2 and a negative 6 made up. So that's not a problem. We just come down here and make this all plus 12, because that would, the nice thing was it didn't hurt anything. So then that would have made this be
A 14.
a 14. Wow. All right, there's another error. We have this as a plus, this is a plus. That makes this be a 9, an 8 here. Still an 8. That makes this a 9, though. This is a 9. Okay. Man. All right. That makes this a 9. All right, so now we have a 9x equals 14. Divide by 9. Divide by 9. X equals...
14 over 9.
Yes. Is that a problem? Is 14 over 9 going to be a problem?
No.
All right. The things that would have been a problem is if we would have had... We said they can't be
a
positive 1 or a 6. That would be a problem. So we got a 14 over 9 and we got it. We just have to be really careful with our negatives and positives. It was just a negative and a positive. It almost made it so it would be a nice number.
Yeah, it did.
Oh, well. All right. We'll just have to make sure we be careful. All right. So most of the time, we were going to multiply by the common denominator. All right. And now the common denominator can have x's in them. We didn't have that previously. The time, though, when we could make our life not so difficult is to just cross multiply. And it'll all be out. When we do that, just be careful with all that multiplying we have to do. Do need to check, though, that it doesn't equal the excluded number of the domain. Okay?
Okay.
All right, we're done.